Okay, let's look at the practice exam 2, problem number 3. Right, let's look at the part A. Right, so we want to evaluate this limit involving trig functions. Right, so remember that we have this useful trig limit. So if you have sine of theta over theta as theta approaches 0, and this is going to be equal to 1. Right, so somehow we're going to try to create this expression so that we can evaluate the limit. Right, so let's do that. So this is going to be equal to, right, first I'm going to rewrite tangent as sine over cosine. So we write it as a limit as theta approaches 0. Alright, then you have a sine of 3 theta, and then you have a theta plus sine of 4 theta over cosine of 4 theta. Right? And then what we want to do is I'm going to actually divide top and bottom by theta and see what happens. So if you divide numerator by theta and the denominator by theta, right, then you will get this. So I'm going to go down here. So you have a limit, right, as theta approaches 0. Right, the numerator would be sine of 3 theta over theta. Right, and let's see, theta divided by theta is 1, and plus, I'm going to actually split, I'm going to use sine of 4 theta here over theta, and times 1 over cosine of 4 theta. Right, and in order to apply this limit right here, the limit here, right, we need to make sure that the denominator here and the expression inside the sign has to be exactly the same thing, and that expression also has to go to 0. Right, then you can see that here this is sine of 3 theta, so we do like to have 3 theta here. So what we can do is we can multiply top by 3 and the bottom by 3. Right, that way you can match 3 theta and 3 theta there. Right, and this doesn't change the quantity because we're multiplying the numerator and denominator by the same number. Right, for this one we would like to have 4 theta, so we're going to multiply by 4 and divide it by 4. Right, then you can see that this limit, right, since theta is approaching 0, this guy approaches 1, and the same thing, this guy approaches 1, and this one is actually not a problem. When you have cosine of 0 is 1, so 1 over 1, so this guy also approaches 1. Right, so what you get is really 3 times 1 over 1 plus 4 times 1 times 1, right, which gives us 3 over 5. Alright, so that's the limit of part A. Alright, how about the bottom one? Right, so approaches are very similar, and what we want to do is we want to match this guy x minus 2, so we would like to have x minus 2 there. So what you can do is we can factor out the denominator, so you have x approaches 2, right? Then by factoring out the denominator, you can have x minus 2 times x plus 2. If you multiply it out, you get x squared minus 4, right? Then I'll put the sign on the first guy, since that way we can match the x minus 2. And then just put 1 here, right? Then you can see that here, this guy is going to approach 1, right? Then this guy is going to go to 2. So what you get is 1 times, right, which really doesn't do anything, 1 over 2 plus 2. So it's going to be 1/4. Right, so that's the limit value for part B. All right, that's it. I hope that this was clear.